Hello everyone, how are you all doing? All good? So welcome to Physics Wala. This is your chemistry class and my name is Mini Sharma. And I'm super excited to see you all here in this ignited batch which is specially for class 10th board student and it is going to be in pure English. So are you all excited? Yes. So let us see what we are going to do today. So my dear students, today we are going to master chemical reaction and equation in one shot. So are you excited? Are you ready? Okay. So how's the Josh? Let me know. Now, first question. When I talk about chemical reaction and chemical equation. So very first question comes out, are these two same or different? So my answer is these are two different things. Chemical reaction is something which is happening surrounding you, around you, and the chemical equation is the symbolic representation of chemical reaction. So are we good with this? So we will be starting this lecture with the same energy. So keep it up, bacha. Here we have the examples of chemical reaction. Very common example. You see your mother preparing the food. That is a chemical reaction. Then you can see the plants are making their own food. The process is photosynthesis. That is again a chemical reaction. If I talk about car rusting of iron, but this is also a chemical reaction. If I talk about the frying egg, coal burning, manufacture of medicine, these all are the chemical reactions. So we are very familiar with these chemical reactions. But what if it comes to write them? Right, in the symbolic form, that will be the chemical equation. So before getting into the chemical reaction, we should understand the physical and the chemical change, their differences should be clear. So very first I can see the physical change. Physical means according to the appearance. So you can see physical change. A physical change is a temporary change. Suppose you have ice, okay, it's melted and form water. Now I can again freeze it and make it ice. So basically it's a temporary change. But if I talk about chemical change, it is a permanent change. It is a permanent change. It's if the rusting started on the iron article, I cannot remove it. Okay, this cannot happen that the iron will be getting its shine back. So that's a permanent change. Now see, in the physical change, no substance is formed. No new substance is formed. Here you can see ice to water, water to ice. Any new product you can observe? No. But in chemical change, there is always formation of new chemical substance. Very much important. Okay. Now number 3, there in the physical change you can see there is no change in the mass. No change in the mass. Whatever the amount of ice you're gonna take, it will be converted into the equal amount of water. So there is no change in mass, but the mass of substance changes when it takes part into the chemical change or the chemical reaction. Next is no energy or small energy is involved in physical change. Basically in physical change there is no much energy required. While if I talk about the chemical change, energy is definitely required. Okay, in the form of light, in the form of electricity, any form. Now see, you can see the example. If this ice is melting, this ice cream is melting, no new product is forming. Okay, so this is a physical change. This bulb is lightening, so there is no chemical change. There is no production of new product. So basically this comes under the physical change. Let's talk about the examples of the chemical change. So this wood is burning. Wood is burning. So there is a new product form, that is the ash. Okay, now I cannot get back this wood again after burning. Can I do that? No. So it is irreversible or it is a permanent change. And also here you can see these are the firecrackers. So firecracker, one burst, they show different colors. Okay, they also release much amount of energy, which is a characteristic of a chemical change. So these are the examples of physical and chemical change. If these are clear, so you can answer this question very quickly. Which of the following is a physical change? So first is the crystallization of sodium chloride, NaCl, from its aqueous solution. What kind of change is it? Check it out. Next is the combustion of hydrogen. If you are burning hydrogen, okay, so it is a permanent change. Rusting of iron is a permanent change. Curdling of milk is a permanent change. So these are the chemical changes, and this is physical one. So are we good with this answer? Great. So here you can also see chemistry. I don't like it. I avoid. But chemistry likes me. I cannot avoid. So this is something just to cheer you up. Now, we have chemical reaction. Very much important. Try to understand what chemical reaction is. Here you can see a process that occurs when matter undergoes a change. This is a chemical change. Chemical change in the composition and involves the rearrangement of the structure of the substances. That is called the chemical reaction. Now, in this reaction, one or more substances are converted into different substances. Suppose I have A, it is going to react with B, forming C plus D. So you can see these are two different reactants and these are two different products. So such kind of arrangement we can see in a chemical reaction only. Now, in this reaction, you will see reactants. Reactants are the species which participate. Okay, so these are the species which take part in a chemical reaction are known as reactants. What about the products? So products are basically, they are formed, they are produced during a chemical reaction in result. Okay, so basically here you can see something is reacting and forming a new substance, that is the product. So when the reactants are reacting, they are taking part, okay, or you can say they are participating in a chemical reaction, while the products are formed or produced in the result only. Are we good with this? Now, reactant and products differ in the physical or chemical property. So we will be discussing the example in the upcoming slides. Now, reason for the reaction. Why these reactions are taking place? Why photosynthesis is occurring? Why respiration is there? So basically your answer is the arrangement of electrons in an atom determine whether it will bond with the other atom. See, every atom, suppose there is sodium, right? Atomic number of sodium is 11. So you see it has the electronic configuration about 281. K shell, L shell, M shell. Okay. Now, it has one electron to donate. Right? So, now it can participate in the reaction because it does not have complete octet. So, there is a one extra electron. Due to transfer of this electron, it will be making and breaking the bond. So basically you can say the electron, the arrangement of electrons in the atom determines whether it will bond with other atom and with which atom it will combine. Suppose there is sodium, suppose there is magnesium, and then there is chlorine. Now magnesium atomic number is 12, chlorine atomic number is 17. Write down the electronic configuration for these two elements. So you will be finding there are 2 electrons in the outer shell of magnesium, while in the case of chlorine there are 7 electrons. So if I ask you, sodium is going to make the bond with magnesium or chlorine, what will be your answer? Yes, of course. Sodium is going to react with chlorine because they are going to satisfy each other with the donation or acceptance of the electron, or I can say transfer of electron. Are we good? So basically, due to this kind of arrangement, atoms undergo chemical reactions. Now, you see the atom with full set of valence electron will not form bond such as helium. It has complete duplet. It will not be participating in reaction. Next, you have the atom with incomplete set of valence electron will bond. Here is the example. Sodium and chlorine are getting close to each other, making bond. Why? To complete their, in the case of chlorine, octet. In the case of sodium, again octet. Are we good with this? Yes. Now we have characteristics of a chemical reaction. Suppose in this room, their chemical reaction is occurring. So how will you believe me? So there are some evidence or the characteristics of chemical reaction. So very first is change of state. What if, suppose I have hydrogen. It reacts with oxygen. Do you know the physical state of hydrogen? Yes, of course, that is gaseous in nature. Oxygen we breathe in, that is also gaseous in nature. They both combine and form water. So what is the physical state of water? What is that? That is liquid. So you can see in the reactant side, two gases get combined in order to form a liquid product. So there is change in the physical state. So I can consider it a chemical reaction. Number 2, change in color. Suppose there is a compound, say you have copper sulfate. In the copper sulfate, what is the color of copper sulfate solution? That is blue color. Okay. Once there is a copper sulfate solution, I am placing iron nail into it. Iron is in solid state. So what will happen? The color of the copper sulfate solution will be fading. Okay. So why there is change in color? So I can also consider it a reaction. That is, what will be the products? Let me know. Yes, FeSO4 plus copper. Okay, so FeSO4 is something green in color. So the color changes from blue to green, or you can say the intensity of color is fading during this reaction. So I can consider it as a evidence of the reaction. Change in color. Next, I have evolution of gas. So that's again very much amazing. Like suppose I have zinc granules and I am reacting them with sulfuric acid. So what will happen? Of course, there will be production of ZnSO4 and evolution of hydrogen gas will take place from the test tube or the beaker in which the reaction is occurring. So basically, this will also be considered as a chemical reaction. Next, we have change in temperature. Suppose I have calcium oxide. Okay, that is used for the whitewashing. So I will be adding water to it. It will be giving me calcium hydroxide and lot of amount of heat will be released. How would I know heat is releasing? So in which suppose there is a beaker in which this reaction is taking place. So this beaker boundary will be heating up. Okay, the temperature of the beaker will increase so that I can understand when these two reactants were reacting together, there was evolution of heat. So basically, this is also one evidence. Number last, that is formation of precipitate. Suppose I have NaCl. Okay. Suppose I have BaCl2 plus Na2SO4, which is sodium sulfate and barium chloride. So if I react these two, these are the aqueous solution of their individual aqueous solution. Okay, now I am mixing them up, so I will be getting BaSO4, which is an insoluble substance which will be settled down into the in the bottom of the beaker. Okay, so basically I got to know there is a precipitation. Insoluble means precipitation and other will be the soluble substance. So basically, why we are discussing these type of reaction? Because we need to understand the evidence of the reaction. Anything is happening, we require the evidence. Why we are studying science? Because it gives you the evidence of whatever is happening around you. So basically, we got to know how we can characterize the chemical reaction. Next is the change of state. So basically, we already have discussed when hydrogen gas reacts with oxygen gas, it forms liquid water. So basically, that is what a chemical reaction. Okay, you can write that reaction back. Change in color, of course, we already have done this. So basically, in this, we had copper sulfate solution in one beaker. Then I placed iron nail into it. Suppose I am placing iron nail into it. After some time, it's about 30-40 minutes, the change in color of the beaker is observed. So you can see it is something green in color. So I can assume there is some kind of reaction that has taken place in this scenario. Okay, so what that reaction is, we already have discussed. Now, next we have evolution of gas. So basically, when the zinc granules are supposed to react with aqueous solution of dilute, or you can say dilute sulfuric acid, we will be getting hydrogen gas, which will be evolving. So how we get to know that this gas is hydrogen or not something else? So we will be placing, suppose this reaction is occurring in this test tube. Okay, so my dear students, you need to understand this reaction is occurring here. If hydrogen is a gas that will be escaping from the mouth of the test tube, now I will have to place a matchstick, a burning matchstick, near to the mouth of the test tube. What will happen? There will be a pop sound. Why? Because hydrogen is explosive in nature. The bubbles of the hydrogen will be burst when they will be coming into the contact of this burning matchstick. So that pop sound indicates that it is a hydrogen gas. So basically this comes under chemical reaction category. Next we have change in temperature. We already have discussed this reaction occurs when we go for whitewashing. Nowadays the Diwali is very much nearby. So basically whitewashing you can easily see nearby you. So this reaction occurs when calcium oxide reacts with water. It gives you slake lime and there is production of heat. Next we have formation of precipitate. We already have discussed the different example. Here you can see NaCl in aqueous is reacting with AgNO3, which is silver nitrate. Silver nitrate. Now they are present in aqueous state. Why? Do you have answers? Sodium chloride. Why not in solid state? They are in the aqueous state. Why? What is the answer? Yes, of course. In the aqueous state, it is very much feasible to change the ions. You can see in the reaction when we will be discussing double displacement reaction, I will be letting you know the reason. So for now, I can see there is two products. One is the sodium nitrate, which is soluble, and the other is silver chloride. Do you recall the color of the AgCl? That is exactly white in color, white powder. So it is insoluble. An insoluble substance is known as precipitation. So are we good with the characteristics of chemical reaction? Great to go. Now we have chemical equation. Of course, we already have done all the chemical reaction, the characteristic. Let's discuss about chemical equation. So chemical equation is nothing but it is a method of representation. What kind of representation? Symbolic representation of chemical reaction is known as chemical equation. So simply you can say chemical equation is nothing but the symbolic representation or the mathematical representation of a chemical reaction. So what if I am seeing any kind of reaction and in the examination I have to write it. So there should be some symbolic form. Suppose rusting of iron. Rusting of iron. So I need to write this reaction. So there will be some symbolic representation. So for iron, I can write Fe. For rusting, the responsible reactants are water molecules and the oxygen present. So I will be writing this and O2. And there will be production of Fe2O3 XH2O. That is the formula of rust. So can you see? It's very much clear. This is the chemical reaction and this is the chemical equation. Chemical reaction. I hope the difference is very much clear now. Now we have chemical equation can be written in three forms. One is the word equation. Suppose I am writing magnesium. Okay. Suppose I am writing magnesium burns in presence of air or oxygen. So this is a chemical reaction, but it is written in the word form. So magnesium burns in presence of air. That is the word form. Now skeleton equation. What is skeleton equation? Or you can also name it unbalanced equation. Unbalanced equation. So I can get an idea that magnesium is Mg. That is reacting with oxygen and forming something MgO. Okay, so that is the skeleton reaction. Okay, equation. Now we have the balanced one. So balanced one is very much required. Why? Because of law of conservation of mass given by, yes, let me know who gave this law. The father of chemistry himself, Antoine Lavoisier. So basically, according to this law, equalization of atoms from reactants and product side should be done. So basically, law of conservation of mass says left hand side is equal to right hand side. What is it? So left hand side we place reactant, while in the right hand side we have the products. There should be equalization. So are we good with these three terms? You can get the chemical equation in this form. Of course, in your NCERT, you can check the word equations. Then the skeleton equation, you can be asked, suppose this is a reaction, you have to balance this. Right? This is the reaction and you have to balance this. So that is the skeleton equation, while the balance equation is done by you only, because we need to follow the law of conservation of mass. Great to go. Now, let's suppose what we have. Essential of chemical equation. So basically, for a chemical equation, it is required that it should be present as a true chemical change. Whatever we were discussing in the chemical change and the physical change. So, for a chemical equation to be written, there should definitely a chemical change that is occurring. Okay. Now, number 2, it should be molecular. That means hydrogen, chlorine, oxygen. In which state they exist? Let me know, my dear students. Hydrogen exists as H2. That is the molecular form. Chlorine cannot stay alone, so it will be forming Cl2. And oxygen present in O2 state. Nitrogen will be present in N2 state. So this is what I mean by molecular. Great. It should be represented a change in the temperature. So if the chemical equation is written, there should be more, it should be more informative. So if there is any change in the temperature, it should be mentioned. Next we have, it should be balanced, of course. To follow the law of conservation of mass, equalization of atom, both the side from reactant and product side should be done. So let's, one question you can definitely expect from balancing of chemical equations. Of course, unbalanced reaction, we don't want them. We want only the balanced equations, right? So how we can balance the chemical equation? So we have two methods. One is hit and trial method. Hit and trial method. Suppose we have this reaction. Fe reacts with H2O and gives you Fe3O4 and hydrogen gas is evolving. So we need to balance this. Let's check how we can balance this. So first you can see here, you can see the iron are in number 3, while the iron in the reactant side is 1 only. So there is no balancing. So we need to balance it. So one, we need to understand we are doing this balancing in step manner. So very first step is to balance the chemical reaction. First draw the box around each formula. Suppose this is the first formula. So I will be making a box around it. Number 2, number 3, number 4. Why we are doing this? You know what? Sometimes it happens. Some students can, get this idea in a wrong way. They start balancing the subscripts also. So we always keep in mind, this is the very first step from NCERT. So basically first we need to, draw the boxes around each formula just to make sure that we are not, there is no change in the subscript during the balancing. So basically to avoid that, we are placing them inside the box. Okay, so you can also see, do not change anything inside the box while balancing the equation. So we are supposed to not to change the subscripts. Okay, now find out the number of atom of the each element. So we need to check how many element of iron are using here. So on the reactant side, 1 is for iron. So I can write it in the form of a table. So I am having element iron, then hydrogen, and the third one is oxygen. So these are the elements. Next I will be writing their numbers. First I will be writing in the reactant side, that means LHS, left hand side, and 2 will be right hand side for the product. So here I can see the iron is only 1 in the reactant side, hydrogen are 2, and oxygen is 1. Are we good? Now see how many irons are present in the product side. So there are 3. How many oxygens are there? There are 4. Sorry, there are 4. And how many hydrogens are there? There are only 2. So basically we can say there is highly unbalancing. So we will be balancing this. So step 1 and step 2 both are clear to you? Great. Number 3, start to balance the equation with the compound having the maximum number of atoms. Suppose this is the reaction, okay? So what is the compound having maximum number of atoms? Is it iron? Is it water? Is it Fe3O4 or hydrogen? Yes, of course. This is the element having maximum number of atoms. So while balancing does not alter the formula for the compound. We are not supposed to alter the formula. We are just supposed to, check the number of atoms on both the side, reactant and product. So basically here you can see, one by one balance the each element on the reactant and product side. So I can see, again you need to make this neat and clean table. So I have hydrogen, then I have oxygen. So in the reactant side and in the product side, left hand side, right hand side. So I have 1, 3, that will be 2, and this will be 2. This is only 1, and this is 4. So this kind of arrangement we get. So basically I will be, managing it if I try to balance it from the hydrogen side. So basically I can see there are 4 oxygen, but this side there are only 1 oxygen. Check this. 4 oxygen, only 1 oxygen. So what I can do, I can place 4 in front of H2O. So what will happen? Check this. Hydrogen will be 8 and the oxygen will be 4. You can multiply these like that way. Great. So we have concluded there will be, I will be multiplying this reactant side to 4. That will be 4. Balanced 4 is equal to 4. Now see. So this is balanced. So if this is balanced, now you will be seeing hydrogens are 8 now. Hydrogens are 8 now, while this side there are only 2 hydrogens. So what we'll be doing? We will be multiplying this hydrogen by 4. So hydrogens are also 8. 8 hydrogen, 8 hydrogen equal. Oxygen are 4, 4 oxygen equal. Now only 1 species is remaining, that is iron. So basically I can see there are only 3 iron and here there are only 1 iron. I will be placing 3. So what will happen? Iron is 3 Fe. Match this 3 Fe. Are the atom on both the sides equal or not? Is this reaction balanced or not? Yes, it is balanced now. So basically you have done, this hydrogen is multiplied by 4. This is multiplied by 4. This will be multiplied by 3. And now you can see in this table, everything from left hand side and right hand side is equal. So next we have number 5. Sometimes the reactions are complex. They will be taking more steps. So what we can do in that scenario, after balancing the number of atoms on both the sides of the equation, finally check the correctness of the balance equation. We have to check it, right? In the previous slide, I definitely checked the reaction. So you have to check the correctness of the reaction. So now this reaction is balanced. All right. Next, then write the symbols of the physical state. It is very much important to make your chemical equation more informative. So basically, let's suppose this is iron. It will be in the solid state. I have placed it. Next is water, right? That is in the gaseous state. In the steam form, it will be reacting with making a solid compound of iron oxide. Next we have hydrogen, and hydrogen is always in gaseous state. So this is very much right. If you write it like that way, it is not completed. Why? Because it is not informing you about the physical state of reactants and product while they were reacting. So are we good with balancing of the chemical equation? Yes, there is another method also, that is ABCD method. Okay, so we will also be discussing that ABCD method. Let's discuss that only. So we have, suppose I do have copper oxide reacts with hydrogen, gives you copper plus H2O. But this reaction is already balanced, isn't it? Yes, this is a balanced reaction. No problem. We will be discussing K plus reacting with water. This is potassium reacting with water, give you potassium hydroxide, and there will be release of hydrogen gas. So we need to balance this reaction. So I will be using another method, that is the ABCD method. What that method say, I will be writing A, B as a coefficient of each reactant and product. So this is A, B, C, and suppose this is D. Okay. Let me write it again. That is H2 and this is D. Right. So basically what I have to do, A is written for, suppose we have the elements K, hydrogen, oxygen. These are the 3 elements involved in this reaction. Yes or no? Of course. So for K I have, suppose K is present with A and C. So with A I can write, this is A, equal to, So the reactant side will be equal to product side. So I will be writing A is equal to C. Why C? Because there is only one K present. So 1 is multiplied by the coefficient, that will be C only. 1 is multiplied by the coefficient, that will be A only. So I can write for K, A is equal to C. Now, for hydrogen, I can see this coefficient is going to multiply by this subscript, that is 2B. Can you see any other hydrogen in the reactant side? No. So I will be writing the equal sign, and next I will be saying the hydrogen is present with C. How many number? Only one. So I will be writing C only. Next I see the hydrogen is present with D also. So I will be writing 2D. Why 2D, ma'am? You can see the subscript, that is 2. My dear student, it will be 2D. So basically, I have also written the equation for H. Let's move to oxygen. So oxygen is present with B. B multiply 1, that is B only, equal to B multiply C. Sorry, oxygen multiply C, that is only 1, giving you B is equal to C equation. So are we good with this? Any problem in this? Now, very interesting turn is that you need to suppose a value of any of the variable or the coefficient. So I can see A and C, C and C. C is common in all the equations. So I will be writing, suppose C is equal to 1. So if C is equal to 1, B is equal to 1 also. Next, if C is equal to 1, A is equal to 1 again. Next is, I will be placing all the values in order to determine the value of D. So what will happening here? 2 into, what is the value of B? 1 equal to C. What is the value? That is, C is 1 plus 2D. Now can you solve this for me? 2 minus 1 equal to 2D. 2D is equal to 1. D is equal to 1 by 2. So I will be getting all the values of the coefficient A, B, C and D. So what I need to do, the next step is, I will be writing these. So in place of A, I can write 1. In place of B, I can write 1. In place of C, I can write again 1. Oh my god. In place of D, I will be writing 1 by 2. Okay, but there is a condition, the chemical equations should be having the coefficient which is a whole number. So in order to do that, because the fractional things don't look fancy, don't look good, so basically I will be multiplying the whole equation by 2. So what will happen, bacha? This K will be 2 multiplied by 2, that will be 2K. This will also be multiplied by 2, so that will be 2H2O. Right? Next, it will be also multiplied by 2, 2KOH. Next, 1 by 2 multiplied by 2, this will be cancelling out and it will be H2 only. Last but not the least, I will be writing the physical states of each reactant and product. K will be solid, this will be liquid. Of course, potassium is a very reactive metal. It will be reacting with water, vigorously making aqueous solution of KOH, and lots of amount of hydrogen gas will be releasing, liberating. So that's the balanced chemical equation. So we already have covered the hit and trial method. Okay. If you like it, you can also do this. And if you like ABCD method, you can also apply that. So ABCD method can be used for the complex reaction also. It is saving your time because calculations are always accurate. But the hit and trial method, there is error. If you are practicing it more and more, both the methods are very much easy to apply. Okay, that's up to you, which is your favorite method to apply. Next, we have the information conveyed by a chemical reaction. We already have discussed this. So basically, you can see it will be telling you about the concentration of reactant can be indicating by putting dilute. Suppose I am using H2SO4 that is reacting with Zn. Okay, so this is the sulfuric acid. Sulfuric acid can be, suppose you are drinking a cold drink. Okay. Any cold drink, your favorite cold drink. So that is the concentrated cold drink. You have the characteristic taste of that. What if I add some water into it? Will there be any change in the taste? Definitely. It will be diluted, no? Diluted. So if this is diluted, that means we have added water into it. So when any acid is or the base is reacting with any metal or any reactant, so we have to write their concentration while it is diluted or concentrated. So for diluting, I will be writing dil. It's not that wala dil. That's a dil only. Okay. And we have the concentrated, the half term for CONC. Okay. In order to make it more informative, so that I will be seeing this and will be saying, okay, that was the dilute acid. Okay. That is more informative. Now, the physical state of the reactant and product should be written. Very much important. Heat exchange during the reaction. If I am going to react this reaction, if I am going to complete this reaction, I will be forming ZnSO4 and there will be liberation of hydrogen gas. So if there is any kind of inference, like I am doing this reaction in a beaker and the temperature of the beaker increases, so I would have to write that whether the reaction is exothermic or endothermic. Okay, we will be coming to that topic also, but again, heat change should be mentioned. Now the specific condition or the necessary condition for the reaction should also be mentioned. For example, I do have AgCl. It decomposes in presence of sunlight only. So this is a specific condition, no? Excuse me. So it will be giving you silver and the chlorine gas will disappear. So this is something, the information that are conveyed by a chemical equation if you write it properly. Now we have a question, that is your homework. You have to write the balance equation for the following chemical reaction. So very first is sodium reacts with water. It gives you sodium hydroxide and hydrogen. Okay, so what is sodium? That is Na. Reacts with water, gives you NaOH and hydrogen gas is liberated. So basically the similar reaction, potassium and water, we already have covered. So the similar way you can attempt this question. So next is the sodium hydroxide. You can see, my dear students, sodium hydroxide is nothing but NaOH. Solution, that means it is in aqueous state. Always remember these things from the question. This is a word equation. What kind of equation is it? It is a word equation. Such questions are given in your NCERT. Okay, so very much important. NCERT questions are always important. Next we have, it reacts with hydrochloric acid solution. That means HCl is also in aqueous state. That's the dilute form, no? So it will be producing, what is it written? Sodium chloride. Sodium chloride is nothing but NaCl. That is a salt. And okay, solution. If it is written as solution, it will be aqueous. And water. Water is a liquid. Great to go. You have to balance this. So basically, first, it was a word equation. I converted it into the skeleton form. And the question is being asked that you have to balance it. Where is the balanced equation? So get it ready. Such kind of question you can definitely expect in your examination. So here you can say this reaction, you can balance this using hit and trial method or the ABCD method, whatever you like. Next is, which of the following is the most informative equation? What that means informative? That means it is giving you the balanced equation. It is giving you the idea of specific condition. That means it gives you the physical state of reactants and the product. Let's check out in which reaction we can see, in which option we can see. So basically here you can see there is no idea of any physical state. Now here it is, but can you see the physical state in the product side? It is incomplete, no? Next we have BaCl2 aqueous reacts with ZnSO4, zinc sulfate aqueous gives you ZnCl2 aqueous BaSO4 solid. But that is correct. In this case, in the fourth case, it is given. Okay, what is the difference between these two? So BaCl2 aqueous, ZnSO4 aqueous. Now we have, okay, there will be one sign like this. Any of these two, we can have the sign which is down-headed arrow. What that represent? What that represent? That represent the insolubility or the precipitate. How would you know if you are, making the solution of BaCl2, barium chloride and zinc sulfate? You are making the, solution. So you see in this reaction, in the beaker, in the bottom there is something settled. Something is settling in the bottom. So what is that? That is BaSO4, and which will be represented by, what if I'm gonna ask you what is this compound that is insoluble in the solution? So you will be saying that is barium sulfate, that is given into the reaction with proper information. And this down-headed arrow definitely suggests that something is insoluble and which is settled down into the bottom of the beaker. So are we good? This is going to be your right answer. Next is the classification of chemical reaction. My dear student, in this chapter we are going to discuss 5 types of chemical reaction mainly. Okay, now how can we classify these chemical reaction? Check out this story. So the chemical reaction involves the breaking of old bond. Okay, what will happen? Breaking and making. So basically when you were in the lower classes like LKG, or you are in the first, second, third classes, so basically then you had a different set of people, different set of friends, and now in the class 10 you have different set of people, right? It is very much, you can say there can be an exception also. There are some kids which are having their friends since then, so I am not discussing that exception. But yes, you suppose your old friendship fades and the new friendship starts to grow. So that is something where chemical reaction can be understood properly. That is the example only. Don't take it seriously. So breaking of old bond, that means you are going away from your old friends and making new friends. Okay, that is the requirement for a chemical reaction to occur. So in order to produce new substances on the basis of nature of breakage of bond or formation of bond, chemical reaction can be classified into 5 broad categories. So breaking of old bonds and making of new bonds. These suggest there will be occurrence of chemical reaction. Are we good with this? Okay, reason should always be clear. Now we have these 5 broad categories. So one is the combination reaction. We also call it synthesis reaction. Why? We will be knowing in some moment. Okay, decomposition reaction, as the name suggests, something is decomposed. Next we have displacement reaction, very much important from the examination point of view. We have double displacement reaction and the redox reaction. I am not at all saying that any of the reaction is less important. Every topic, every reaction is very much important. But yes, there are some topics which are, examiner's favorite. So displacement is one of them. So let's check type of reactions are these. Now, there are some reactions which are based on the extent of heat exchange. As I told you, change in temperature. So calcium oxide reacts with water and forms calcium hydroxide and releasing the amount of heat, making the beaker heat up. So that is, there is exchange of heat. Whether the reactants are absorbing the heat or they are, releasing the heat. So basically, we can classify all the five type of reaction into two broad categories, that is exothermic and endothermic. Exo means exit and endo means enter. Okay, if you are required to break this pen, so you will require some kind of energy, no? So I will be, having some kind of energy to break this pen. So I am giving the energy to this pen. So the energy is entering. Okay, what if there is a reaction of calcium hydroxide, the energy was releasing, so that was energy exit. That's okay. So that are exo and endothermic kind of reaction. We will be talking about them using the examples. So reaction in which heat is released or given out or vomit out, that is called exit. Thermic means, exo means exit, right? Thermic is related to temperature, no? So temperature is related to heat again, right? So exothermic is clear, the reaction in which heat is released along with the formation of product. Definitely product will be formed. These kind of reactions are known as exothermic reaction. In these reaction, the reactant energy is more than that of the energy of product. How is it possible? We will be knowing what that means in a moment. Suppose, what is endothermic? Endo means enter. Thermic again is associated with temperature. Great. So endothermic reactions are those reactions which absorb the heat in heat or energy. Okay, absorb or eaten, or you can say they require by the reactants to complete the reaction in order to form the new products. That is called the endothermic reaction. Endothermic reaction, the energy of reactant is usually less than that of the energy of product. Now see what can be the example, what can be the appropriate example. So basically in the case of exothermic, we can take the example of respiration, or no? Yes or no? So in respiration, glucose. Now we will be discussing about respiration a bit. So basically when we eat food, okay, that is very much complex. So food undergo many biochemical reaction in order to digest that. So the food from the complex substance is converted into the simpler substance by some biochemical reaction and the enzymes. So I will be talking, suppose a food is converted into the carbohydrates. So carbohydrate is a complex substance. Okay. Now, my dear student, that will be converted into the simpler one, that is glucose. Now, this glucose will go to the cells. You know, that is very much, basic in the biology. So basically, this glucose in your cell will react with oxygen that is present inside the cell and will be forming CO2 plus H2O, and there will be release of energy, production of energy. So that's the respiration process. That is one kind of exothermic process. Okay, so basically, is this clear to you? Yes. Now you can see the energy is releasing. So suppose you have something in axis. Okay, so you are having something in excess, you will be donating that. So reactant most probably will be having much energy. That's why they are giving out, or they are vomiting out the energy in the forms of product. Are we good? So basically I said that the reactant's energy is higher than that of product's energy. Energy of reactant is higher than energy of product. Good to go. Now we have the endothermic reactions. As you know that the example can be, let's suppose I have calcium carbonate. Okay, that is the limestone or the formula of marble or limestone. Do you recall the color of calcium carbonate? Can you write it for me? So basically, when I want to decompose this calcium carbonate or anything like this pen, I want to break this. So I will have to put some energy, right or wrong? So basically, when I will be decomposing this calcium carbonate, it will not decompose by itself. So there will be requirement of heat, that is denoted by this delta. So it will be converted into calcium oxide and CO2 gas will be released. Now, it says that the reactant's energy is less than that of products. Why we are saying that? Suppose calcium carbonate could not decompose by itself. It is eating up some energy from the surrounding. Okay, so the energy was less from reactant side. So I can write the energy of reactant is lower than energy of products. Are we good with this? Yes. So this is the broad classification of all the kind of reactions in the universe, exothermic and endothermic. Now find the incorrect match. You can definitely expect such kind of questions. The decomposition of vegetable matter is exothermic. Is it true or false? Yes. When decomposition of vegetable matter occurs, it creates humus, release the energy in the form of heat. So, if it is releasing the energy, it will be exothermic or no? Yes, true. Next we need to find out the incorrect match. Respiration. We just have seen this reaction, respiration, that is exothermic reaction definitely. Composition, decomposition of calcium carbonate, we already have seen this is not exothermic. We provide energy to calcium carbonate in order to decompose into calcium oxide and CO2. So basically this is endothermic. It is matched incorrectly. So this is the answer only. Burning of natural gas, that is also exothermic. You know, any burning of the fossil fuel or any fuel, that is exothermic because that release energy. So we are up to combination reaction. So what are combination reaction? As the name suggests, combine. Something to combine. So basically we have two tiny reactants. One and this is two. They both combine together in order to form a single product. Single product. These are the key points you always need to recall. Two reactants, two or more reactants giving you a single product, that is the combination reaction. And we also call it synthesis reaction. Why? Because we are synthesizing, we are forming a single product. Synthesis means formation. So basically formation of single product, that's why we call it synthesis process. Now combination reactant in which two or more reactant combine to form a single product is called combination reaction. Example, very much important example. You can star mark here. Calcium oxide reacts with water, gives you calcium hydroxide and releases lot of amount of energy, or you can say heat. So this is a combination reaction. You can say there are two reactants, no? Calcium oxide and hydrogen. My dear students, they are going to combine together in order to form a single product. So that is coming under the category of what? Combination reaction. So one more thing I would like to ask you, combination reactions are exothermic or endothermic? How to know this? What can be the easiest way to understand this? Tell me. So basically, combination reactions are exothermic. You can see this energy. So basically, sometime in the reaction, it's not even written. Okay, you have to check out which reaction is, exothermic or endothermic. So how will you get to know? So basically, in the combination reaction, two reactants are combining. Suppose you are trying to, in your friend circle, you are very much new and you are making your bond with each and everyone. So what will you be doing? You will be releasing your attitude and will be getting into the flow of the friend circle, isn't it? So basically, we all have the attitude, maybe good, maybe bad, doesn't matter, but yes. So in order to maintain that friendship, we release the attitude time to time. So similar way, the CO2 wants to combine with hydrogen, so it will be releasing, and it also will releasing some kind of attitude. In the term of compounds, we will be calling it energy. Yes or no? Great. So they are releasing energy. So when there is a combination, release of, when new bonds are forming, no, there will be release of energy always associated. It will be telling you that it's a kind of exothermic reaction. So are we good? All you can say, usually combination reactions can be exothermic in nature. One more example we just have studied, that is respiration. That was also combination reaction. Glucose combines with oxygen that is present in the cell of the body. So they both get combined and forming CO2, H2O and energy. So these are the very much important examples you should recall. Most important, you should understand, no? So basically, next we are up to decomposition reaction. Here you can say, see, Shinchan, thinking about how many type of decomposition reactions are there. So basically, what are decomposition reaction? As the name suggests, something is decomposed. So basically, suppose what can decompose? That will be in the bigger size. So you can say there is one reactant, a huge reactant. Okay, so this huge reactant in presence of any kind of energy, okay, any kind of energy, nothing can break by themselves. They don't have tendency to break. Okay, so you can say your chair cannot break itself. Either you will be breaking it or the time will. Okay, so basically everything require energy to break down. So it is breaking into one substance and the two substance. So you can say there is only single big compound. Big means not like this big. It will be having multiple atoms like Fe to FeSO4, calcium carbonate, lead nitrate, kind of these things, right? So it will be dissociating into corresponding product. You can see there are two products, right? Now, so basically that was a complex one and this is the simpler one. We can say this. In the decomposition reactions are very much important. In fact, I told you, no, in the digestion of food, the food is very much complex in order to digest. So it is decomposed. It is decomposed. Yes, you heard right. It is decomposed into the simpler substances. So we get the energy to learn, to talk, to go, to walk, to dance, everything. So basically, decompositions are very important. Now, my dear students, I will be asking you, decomposition reactions are exothermic or endothermic? Let me know first. So my answer is these are the endothermic reactions. Why? Because as I told you, no, every substance require kind of energy in order to dissociate, decompose, disintegrate. So it will be absorbing the energy, so it will be endothermic, entering the energy into the reactants. So are we good with decomposition reactions? Now, there are three type of decomposition reaction. One is the thermal. Thermal means related to temperature. So if you are heating the substance, suppose I am heating this substance, so it will be decomposed. Okay, why? Because with heat, as the temperature increases, kinetic energy of the particles also increases. So they will be moving here and there, right? When they will be moving here and there, so there will be decomposition. Okay, right? So thermal means temperature. So if I am using temperature or heat in order to decompose, the decomposition will be known as thermal decomposition. Next is photolytic. Photo means, it's not like DP photo. No, it's like photo means sunlight. Now, if anything, any substance that decompose in when it is exposed to sunlight, that will be known as photolytic decomposition. Last but not the least, in our syllabus, we also see electrolytic decomposition. Electro means electricity, and lytic means breaking down. So in the presence of electricity, if any substance breaks down, that is called electrolytic decomposition. That is very much easy. So here we have thermal decomposition. You can see the temperature is very much high. So basically the decomposition, when the reaction is carried out by heating, that is called thermal decomposition. For example, we have the decomposition of limestone. We already have discussed limestone is what? CO3. That will be decomposed, will be making calcium oxide and CO2. This gas is very much important. How will I get to know that the gas that is produced in this reaction is CO2, not oxygen? So I will be taking one activity. I will be taking one burning candle, and I will be placing this burning candle in front of the mouth of the test tube in which this reaction is occurring. So what will happen? Tell me. If this CO2 is releasing from the mouth of the test tube, it will blow this candle. Yes or no? Blow this candle. Why? Suppose it's your birthday and there is cake, there is everything decorated. So basically you also have that candle on the cake, so you blow it. So we breathe in oxygen, we breathe out CO2. So CO2 is not a supporter of burning, not a supporter of this flame. So if this is the gas CO2, so it will blow this candle, and I will get to know that this is CO2, carbon dioxide. So are we good with thermal decomposition? First example. Now I can take also one more example. Suppose I have lead nitrate. Okay, so this lead nitrate is heated. When we heat this lead nitrate, the very interesting part is this is colorless or white in color. This compound is colorless or white in color when I will be heating this. So it will be producing reddish brown fumes. And there will be a residue that is in yellow color. Can you tell me who contribute these colors? Let me know. Okay, you can balance these reactions, okay? You can definitely balance, you can definitely write down the physical state of each of the reactant and product on behalf of me, right? So basically when I am decomposing this, so it will be decomposed into lead oxide, which is yellow in color. Residue that is in solid state, no? NO2 is gas, oxygen is also gas, and we know that oxygen is colorless, odorless. But NO2, nitrogen dioxide, is reddish brown in color. Very much important. These colors are very much important. So they can be asked you, there is a X compound that undergo decomposition on heating, so that we observe there is a production of reddish brown color of the fume. What is that X compound? Write the balanced chemical equation for the same. So such kind of questions can be asked from this topic. So we know that reddish brown color fumes are associated with nitrogen dioxide because oxygen is colorless, odorless, while lead oxide is solid in state. Solid do not form fumes, right? So that is the another thing. We have one more example. So I have one more example that is about FeSO4, that is iron sulfate. So basically iron sulfate heptahydrate. The color is green. So I will be heating it. So when they are water molecule and I am heating this compound, what will happen? Very first the water molecule will disappear. So it will be making FeSO4, which is dehydrated. So color change from green to colorless or white. Okay, in the chemistry we can consider colorless and white are same. Okay, now I will be heating it more. I will be heating it more and it will be converting into the corresponding Fe2O3 plus SO2 plus SO3. So the color comes from green to colorless, colorless to brown. This is the rust, no? Rust has a brown color. So basically that solid or the residue is brown in color, while the SO2 and SO3, both the gases are colorless but not odorless. They have characteristic smell of burning sulfur or the very pungent smell. So are we good with these three reactions? Very much important according to paper point of view. 1, 2, thermal decomposition of calcium carbonate, thermal decomposition of ferrous sulfate, thermal decomposition of lead nitrate, and the corresponding change in color. That was very much interesting. Now we have photolytic decomposition. You can see sun is here. So these reactions occur in the presence of sun only. So basically, let's suppose I have this china dish and I am placing AgCl into it. Okay, let's suppose it is AgCl. AgCl, silver chloride, has white color powder. Okay, when I expose it in front of sun, suppose there is sun. Okay, in presence of sun, it will decompose. There will be change in color and the color will be changed from white to gray. So that's a characteristic of chemical reaction. No change in color. So I will be letting you know what kind of reaction is occurring here. So AgCl is decomposing into Ag and Cl2 gas. So basically this is the white color compound while this is the elemental silver. So you know the color of elemental silver, which is gray. Okay, so white to gray. The change is from white to gray. And the Cl2 gas is colorless, will be disappear. Now I have one more example, that is AgBr. The color of AgBr is pale yellow color powder. It will be decomposed. Suppose the sunlight is shown by H mu. Okay, that will be H mu. You can write it like that way. Also you can write here like sunlight. In presence of sunlight, this is the specific condition in which the reaction is occurring and you have to mention it. So basically this is going to decompose into Ag and Br2. This is also silver gray. From pale yellow to silver gray, change in color. Interesting? No. So these two reactions are basically used in black and white photography. White photography. So are we good with this? Great. So now we are going to discuss about electrolytic decomposition reaction, and in our syllabus it is about water. Water is being decomposed in presence of electricity and it will be decomposed into H2 and O2 gas, right? So when the substance is broken down into the substituent in presence of electricity, that will be electrolytic decomposition reaction. So electrolysis of water, what will be that? It is the decomposition of water into oxygen and hydrogen, just like the reaction you can see. When electric current is passed through the water, and you will see the reaction. How it proceeds? Let's check. So in this reaction, we have an apparatus, that's a plastic mug. Okay, this is very much important to understand how this reaction takes place. So basically this is a plastic mug we will requiring. Next will be the water which is present inside this mug. Next we have inserted two graphite rods. Here you can see these are the two electrodes. Now these electrodes are connected to the battery having capacity up to 6 volt. Now one terminal which is negative named as cathode, and the electrode which is connected to positive terminal of the battery is anode, and which is positive in nature. So these are some important terms you should know: cathode, negative, anode, positive. Now see, in this mug we have water, but water cannot ionize, can't be ionized. So how can we ionize them? So water ionize means it cannot be broken down into the ions. If it will not be able to break down into the ions, how this electrolysis will take place? So we will be adding few drops of H2SO4, right? Dilute H2SO4. That's a good, that will be a good electrolyte that will be decomposing water into ions, right? So it's a very helpful. So the function of H2SO4 is clear here. Yes, it is making the water to ionize, to get ionized. Next we have these two test tubes which are inverted. Okay, so I will be having two test tubes in which water will be filled, and I will be placing them in invert way on these two electrodes. Now everything is clear in the apparatus. Now what will we do? Now the electric current is passed. What will happen? Bubbles will be formed in these two electrodes, in these two test tubes. So that is the observation. So what is happening there? What are these bubbles representing? Liberation of gas. Okay, liberation of gas. So here we have cathode. At cathode, what kind of charge will be accumulating? Of course positive, right? So here reduction will take place. The reactions are not involved in our syllabus, so don't take that burden. So basically at cathode reduction will take place and there will be liberation of hydrogen gas. And at anode is positive, and there will be oxidation that will be taking place, and liberation of oxygen will be there. So you can see at this, you can see the volume also. Try to check the volume. The extent of volume is different for both the gases. That is in 2:1, 2:1 or 1:2. 2 is for hydrogen and 1 is for oxygen. So the gases which are liberated during the electrolysis of water are not in the same in terms of volume. The ratio is 2:1. So basically this is all about your electrolytic decomposition of water. Are we clear? Oxygen is liberated as anode, and at cathode hydrogen is liberated. How can we, recall this for a longer time? Sometimes students are very much confused. So let me tell you, my dear students, reduction is something addition of hydrogen. Yes or no? You just need to understand at cathode reduction is taking place. Reduction means addition of hydrogen. So there will be more collection of hydrogen at this electrode. While on the other hand, you can also memorize this anode. Anode, there is oxidation that is taking place, and when oxygen, what is oxidation? Addition of oxygen, yes or no? So oxygen will be liberating on anode. That is all clear. So it was all about your electrolytic decomposition of water. Already I have discussed what can be the possible way out to, have some questions. Why we are adding dilute H2SO4? What is the ratio between the gases that are liberated on two particular electrodes? What is the gas that is going to accumulate on cathode, and what is the gas name that is accumulating on anode? That is all in our syllabus. Now, this is a sample. You can see this question is from CBSE sample paper. So, can you answer this? This is what we are doing in the activity. You can see, my dear students, this is the activity for burning the magnesium. So, when we are burning the magnesium, so what will happen? What is the observation? Yes, there is dazzling light that produced during this activity, and also we collect some white color powder that is nothing but magnesium oxide. So what can be the right observation for this activity? So let's check. Brown powder of no, there is no brown powder thing in case of magnesium activity. Next is the colorless gas that turns lime water. No, nothing to do with lime water experiment. This is magnesium burning in presence of air. Now magnesium ribbon burns with brilliant white light. That is great. That's going good with us. So this is the option C is correct. Reddish brown, no, not at all. Reddish brown is related to decomposition of lead nitrate. So option C is correct. Now let's move to the next slide, which is very interesting. Colors. So basically chemistry is all about colors. Chemistry is all about chemical change, and one of the evidence of chemical reaction is change in color. So basically these colors you have to recall for your, to get the full marks, because in the you will see there are many questions which are case based. There will be X substance which is green in color, and after decomposition it will be turning into reddish brown. So what is that? So these questions are related to colors, right? So basically you need to understand that ferrous sulfate, that is known as green vitriol. Copper sulfate, that is known as blue vitriol. Now vitriol is nothing but a chemical term for sulfates, and being very specific, these sulfates for the metal iron and copper. Is that clear? Yes. So how will we recalling these colors? So basically we can create some tricks, like suppose this is iron. Iron can be related to Iron Man. Okay, and the suit of Iron Man or the dress he wears is very fascinating, reddish brown in color, or not? Reddish brown. So can you check here? Fe2O3, which is the color of rust, that is reddish brown. That is the oxide of iron. Iron Man, reddish brown coating. So that is it. Now this reddish brown coating, or you can say the Iron Man suit, is exposed into sunlight or heated up to a greater extent, it will turn into black. So the color of Fe3O4 is black. Yes, you can, these are the terms how you can recall these colors. Now see, we have Iron Man. Iron Man, friend's name is, that is Hulk. And Hulk's color is, what is that? That is green. So when there are 7 water molecules, we are talking about the friend of Iron Man, that is nothing but Hulk. So it will be in green color. Okay, now this line is clear. let's suppose we have copper sulfate, which is blue vitriol. So basically here we can write cub. What are cub? The babies of lions and tigers. We call them cub. So cub is what? Copper is blue. It is saying copper is blue. I am writing here copper is blue. Don't forget that. So copper is blue. You will be recalling it when there are 5 water molecules. Now suppose we have copper oxide. There is an activity in, when we will be discussing oxidation, we will be getting copper oxide is black in color. Now suppose you have a copper article. Okay, over the time it will be covered with a green layer. What is that? That is the corrosion of copper. That is the, that process is called corrosion, and that green layer is basic copper carbonate. Okay. So my dear students, you need to recall that green layer is nothing but the corrosion of copper metal, and you can call it basic copper carbonate. That color is green. Now, my dear student, all the lead compound, if I say most of them, so that are colorless in nature, but there are 2 lead compound. One is PBI, lead iodide. Okay, that will be I2. Right? So lead iodide is golden yellow. That is very shiny, very attractive color. And the PBO, which we found on the decomposition of lead nitrate. Right? So basically this is yellow in color. Next we have Ag2S. Suppose you are wearing something, some silver article. Over the time it will be reacting with oxygen and the water molecules or the H2S gas present in the atmosphere, and it will be having a coating of black color. So what is that? That is a corrosion of silver. So that will be having a black coating, and that is due to this compound formation, that is Ag2S. So are we clear with this color? Yes or no? Because these colors indications are very much important. You can definitely expect 1 or 2 questions related to change in color. So next we have displacement reaction. Before starting this, I would like to give you an amazing example. You see, there is a kid, little kid, okay, that is playing into the ground, and he's very much happy. Then there is one powerful, stronger, taller boy came. Bahubali came. So what he gonna do? He wants this ball. So he will be taking it. Why? Because he is stronger, he is taller than the little boy. So he take this ball and go away. Now you can see this little boy, this poor little boy is left alone. So you can see there is displacement, there is shifting. Okay, so this shifting is called displacement. And this can happen with everyone. Okay, sometime in our childhood this may happen, this would have happened to us also. So this is something that a bigger and taller, a stronger boy can displace this ball from the little boy. That little poor boy is standing alone. So what we can conclude? We can conclude that in terms of metal, the more reactive metal, the more reactive metal means, see, metals are reactive. How we can say that? So metals are supposed to lose the electron. So the metal which loses the electron faster, that is known as more reactive metal. So in the class also every student is studying, right? But we call toppers to them who are getting the full marks. So they are more reactive. Similarly, okay, that was the example only. You all study well. So basically here I can say there are 2 metal, 1 and 2. Suppose 1 and 2. Okay, so what can we do? So basically in this reaction, we can say that there will be one reactive, or you can say more reactive metal than the other. So I have already told you, in the terms of reactivity, we will say the metal which is losing electron faster than the other, that is more reactive metal. And how will we get to know? There is a reactivity series to help. So basically here you got an idea. Suppose M1 and M2, they are two metals. Okay, suppose M2 is more reactive. So what will happen? I have a reaction, say H2SO4 and Zn. That will be making ZnSO4 and H2. Can you compare this reaction to this? Yes, this is the boy, this is the ball, this is boy, this is the ball, and this is the another taller, stronger boy, boy 2. Okay, so what is happening? This ball has gone to the bigger and the stronger, taller boy, and this little poor boy is here only. So this is how these reactions take place. Displacement reaction, the shifting, we can call it. So basically here we can conclude that this is the specter ion. Okay, we will be calling it specter ion. So there are only three character, metal 1, metal 2 and the specter ion. And the displacement is going to happen for the specter ion. So what is specter ion here? That is SO4. Okay, so let's move to the next slide to understand more, to have more clarity. So in NCERT, you will see there is iron nail. Check this iron nail. Okay, this is very shiny. Now, we are going to place it into the blue colored aqueous solution. So can you tell me what is this solution? Blue color? Yes, copper. Cub. Copper sulfate solution. This is copper sulfate solution. Okay. Now you can check copper sulfate. After some time, it is found that intensity of the blue color of the solution slowly decreases. So the blue color is fading away and we are getting the color change from blue to green. So that is greenish in color. Okay, you can write this is before adding this iron nail into the solution, and this will be the after observation when you are placing this iron nail into this copper sulfate solution. So you can clearly observe the change in color from blue to greenish color. So, and the iron nail becomes brownish in color. Why? Because of deposition of copper. So, can you tell me what is the reaction that is happening here? So, we had copper sulfate. Okay, this is copper sulfate. Iron means Fe. Now, it will be producing FeSO4 and deposition of copper that is occurring on the iron nail. Also, you can compare the iron nail. Can you observe the change in color of the iron nail? Half of the iron nail is something brownish in color, while before we see this is very much shiny. So what is happening here? There is displacement. So this is your metal 1, your metal 2. This is the specter ion. And now you can check the displacement. This specter ion is displaced to metal 2 and metal 1 is all alone. So this is the displacement reaction. Now see, we have one question from the CBSE sample paper from this topic. It is very much important. Now on placing a copper coin in a test tube, you are placing, let's suppose you are having a test tube and you are adding a copper coin in this, containing the green ferrous sulfate. Suppose this is the green ferrous sulfate solution. Okay, ferrous sulfate solution, which is green in color. So it will be observed that the ferrous sulfate solution. So what can be the answer? You have 4 options. Turn blue and a gray substance is deposited on the copper ion. Is it true? No, definitely no. So basically there is a reaction FeSO4 plus copper. Copper is the coin. Okay, what will happen? No reaction. Why? Because copper is less reactive. Copper is that little boy who cannot displace this Fe. Right? So you have to recall this. So what can be the right answer? Turn colorless and gray? No. turns colorless, no, there will be no change, no reaction, remain green and no change in the copper coin, right? Now see why this happens, due to this reactivity series. This is very much important. In the displacement reaction, you have to recall this reactivity series. In this series, all the metals are placed in decreasing order. Decreasing order of their reactivity. These are arranged into decreasing order of their reactivity. That means the potassium which is placed on the top is highest or more reactive, most reactive. Okay, while platinum that is placed in the bottom, that is the least reactive. That is very much easy to understand, right? Now there is hydrogen that you can see. Hydrogen is not a metal, then why it is placed here? So that is for the reference. Reference only. What kind of reference, man? So my dear students, you need to understand the metals that are placed below hydrogen cannot displace hydrogen into their acid or water. Okay, water and acid both have hydrogen, so these metals will not be able to displace that when they are going to react with acid and water, while the metals which are placed above hydrogen will be displacing hydrogen in their acid or water solution. So are we good? Why hydrogen is placed here? For the reference only, to understand what are the metals that can displace hydrogen from water and acid, and what are the metals that cannot displace hydrogen from acid and water. Now we see potassium, sodium, calcium, magnesium, aluminium, zinc, iron. There are n number of metals. So how would we recall them? So whenever you are going to do a question related to displacement reaction, it will hardly take 15 to 20 seconds to write this whole table. How is it possible? So give me a moment. You will be writing P for please, S for stop, C for calling, and calcium also, M for me, Al that is for aluminium, A, zebra, I for instead, try, learn, how, copper, marry, silver and gold, Ag and Au. Okay, that is silver and gold, and platinum is all, that's the most expensive metal. So when hydrogen is going to marry gold and silver, it will be presenting platinum ring. So you can recall it like that way. So basically, please, P for please, P for potassium, the symbol is K, don't forget that. Now stop means sodium, S for stop, S for sodium, symbol is Na. Now calling, calcium, Me, magnesium, A, aluminium, zebra, zinc, instead, iron, try, tin, we have learn, lead, how, hydrogen, copper, marry, mercury, gold and silver, giving the platinum ring. So basically that's the story. You can write this into 15-20 seconds. Make yourself that's efficient, that you can write this reactivity series in 15-20 seconds using this trick, and the question will be solved. So right now we have discussed FeSO4 plus copper, and I said there will be no reaction. Why? Check this. So copper is placed here. My dear students, see, copper is placed here, and when you compare, iron is placed above copper. So which one is more powerful, more stronger? Iron. So this spectral ion will be with the powerful one. Okay, this is something like in the biology also, discuss survival of the fittest. So which metal is more fitter? That is the iron. So the spectral ion will be connected to the powerful metal, and the lesser powerful or lesser reactive metal will stay alone. So this kind of question you can definitely expect in your examination. Now we have one more question from your CBSE sample paper. Here you can see there is a student, Kirti, added dilute hydrochloric acid, HCl, into 4 metals, recorded her observation that is shown into the this table. Select the correct observation and give the chemical equation of the reaction. So here we see you have to write that reactivity series fast. So here copper is reacting with HCl. There is any evolution of gas? Yes or no? Let me know. Is there any evolution of? No, there will be no evolution of gas. Why? Because copper is less reactive than hydrogen, right? Hydrogen, how? You will be, we will be recalling it like that way. How copper marry silver and gold. So that is how copper. So you can see copper is less reactive, that is placed below hydrogen, it will not be able to replace it, so there will be no reaction. So there will be no evolution of gas. That is done. Now iron is reacting with HCl. Will there be any evolution of gas? Definitely. Iron reacts with HCl, give you FeCl3 and liberation of hydrogen. Why? Because iron is more reactive than hydrogen. Magnesium, again there will be evolution of gas because magnesium is reactive than hydrogen, forming MgCl2 plus evolution of hydrogen. Next we have zinc. Zinc reacts with HCl, gives you ZnCl2 and hydrogen gas will liberate. So this is your answer. You have to write all the reactions related to these observations. So I have solved it for you. Now double displacement reaction, that means exchange. What exchange? Exchange of spectral ion. Okay, spectral ion. So there will be 2 metals, M1, M2. There will be one spectral ion here, second spectral ion will metal 2. They will be displacing each other. So it will be like M1S2, M2S1. Can we write it like that way? That is your chemical reaction in the case of double displacement. So here we can see the reaction in which there is exchange of ion between the reactant and they give rise to the products, that is called double displacement reaction. On mixing silver nitrate, suppose we have AgNO3. These reactions are the most easiest reaction, believe me. So this is reacting, this reaction happened, the condition is it should be in the aqueous form. Okay, it should be in the aqueous form. So you see silver nitrate, that will be in the aqueous form. Because in the aqueous form, this is very much easy to exchange the ions. It cannot happen in the solid state. So we will be making the aqueous solution in order to double displacement take place. Now we have sodium chloride, NaCl. Aqueous. What will be the products? Let me know fast. So this is a very much easy way to write the double displacement reaction. When there are 2 metal, 2 spectral ion, you can divide the aqueous solution, that is AgNO3. How will you do that? Basically all the compounds which are salts are generally ionic. And there is a rule to write the ionic compound. First cation will be placed, after there will be anion will be placed. That is how we write it. So basically this is an ionic salt. So I can, disintegrate it. So one part will be positive, one will be negative, one part positive, one will be negative. So how can we write the answer for this reaction? You see, this positive part, we all know positive negative attract. So this positive part will be attracting this negative part and making AgCl. Now this Na positive part will be attracting this NO3 part, that will be NaNO3. Okay, now in the double displacement reaction, sometime it happens there is one insoluble product that is formed. What is that? Insoluble means something that is not soluble into the solution, that will be accumulating in the bottom of the beaker, right? So that we call precipitate. Precipitate. Okay. So here you can see in this reaction there is formation of precipitate. Are we good? Yes. So your homework is, let me know what out of AgCl and NaNO3, which one is making the insoluble precipitate in that reaction. So basically next we have very important barium sulfate. Sorry, that is sodium sulfate. I will be writing the formula. That is in aqueous state, that is mixed with barium chloride. Again aqueous, will be forming products, corresponding products. What will be them? Disintegrated. Disintegrate. Positive, negative, positive, negative. You have to make the formula, that will be NaCl, of course, and BaSO4. Okay, so BaSO4 is the precipitate here. That means it will be in this test tube. We have, suppose this is Na2SO4. Okay, in this different test tube I have BaCl2. So when I am going to add these two solutions, what will occurring? There will be formation of precipitate, you see. Okay, and that is settling into the bottom of the beaker. So that is what I call the precipitate. This is BaSO4. Okay, and my dear student, the reaction in which precipitate is formed can be also known as precipitation reaction. Precipitation reaction. Okay, we will be discussing about it in a moment. Again, we have one more activity from NCERT. When lead nitrate, suppose I am making lead nitrate solution. This is the lead nitrate. Okay, the previous slide was colorless, lead nitrate solution. Now I am adding another solution of potassium iodide. So what happens? There is formation of yellow color, PPT, precipitation, insoluble. So what is the reaction that is occurring here? Let me know. PbNO3 reacts with Ki, forming what? Let me know. Use my formula of positive and negative and let me know what is this beautiful precipitation. Yes, that is what? PbI2. Okay, that is the your PbI2. And in order to show whether it is a precipitate or not, we use this down-headed arrow, right? That shows it is insoluble, that is settled down into the bottom, right? Next we have KNO3, which is soluble. Okay, which is soluble, that will not be observed. But whatever is not soluble, that will be settling down into the beaker, that will be known as precipitate. So these are the very important activities associated to double displacement we have in the NCERT. Now this question is from the sample paper, very much interesting. Try to check this kind of reaction. What we call them? And this kind of reaction. Check here, metal 1. This is metal 2. And this is the spectre ion. Okay. Now see, this spectre ion has displaced only once. So can I call it displacement reaction? Tell me yes or no. Displacement reaction. Okay. Now see, I have metal 1. This is metal 2. Spectre ion 1. Spectre ion 2. And I can clearly check that these spectre ions are exchanged. So what kind of reaction is it? This is double displacement reaction. Are we good with this? Can you give the example for these reactions? Definitely. You can have numerous examples. We have discussed many. Now suppose we have precipitation reaction. As the name represents, there will be formation of PPT, or I can call it insoluble. So in the double displacement reaction, we have already discussed what is precipitation. Okay, during the double displacement reaction, one product is insoluble and that insoluble substance is known as precipitate. And whatever the reaction is occurring, there is formation of precipitate, we can call it precipitation reaction. So the reaction in which insoluble substance is formed is called precipitation reaction, and this insoluble substance is known as precipitate. Are we good with this? Yes. Now we have neutralization reaction. So neutralization, as a name represents, it is going to neutral something. What to neutral? Suppose I have one acid reacting with a base, will be forming salt plus water. This salt is neutral, so is the water. So basically this acid and base has neutralized each other's effect, and that's why we call it the neutralization reaction. So how this occurs? Let's suppose I have HCl, that is NaOH. Okay, so as I told you, when you have such kind of interface, what you can do? Disintegrate them. Thus, this disintegration should be very much carefully. You have to do it. Okay, so first part is positive, second part is negative. First part is positive, second part is negative. So what we gonna form? HOH will be forming water, and this Na positive Cl negative will be forming NaCl. Keep in mind, cation first, anion later. Okay, this is how you gonna have your products. Now, how this happens? Let's check the mechanism. So here you can see HCl decompose into H positive and Cl negative ion. Similarly, NaOH in the aqueous will be decomposed into Na positive OH negative ion. What will happen when I mix them both? So these Na positive will be accumulating, will be making the bond with Cl negative and OH with hydrogen. So this is how we get the NaCl and H2O as a product. So now, can you tell me, can I call it a double displacement reaction? Yes or no? Yes or no? Yes. We can call it a neutralization reaction, can be a double displacement reaction. So now there is one more question. As I told you, in double displacement reaction, there is, formation of precipitate. DDR. There is formation of PPT, and due to which we call it precipitation reaction. Are there any other reactions which are DDR but there is no formation of precipitate? Yes, these are the neutralization reactions. I can take you one more example to make it more clear. No? So we have, suppose we have H2SO4, that is the acid. We have KOH. Tell me, what are the products? So basically, I will be disintegrating them like this. Positive, negative, positive, negative. So my products will be K2SO4, that is aqueous, and H2O. Okay. So basically, there is no formation of precipitate. Right? So there are two types of DDR. Okay, double displacement reaction. One which form precipitate are known as precipitation reaction, and one, those who do not form precipitation, are the neutralization reaction. So are we good with this? Great. Now redox reaction. Most of the students get confused in redox. So what is redox? Redox itself is reduction and oxidation. So suppose we have a reaction in which oxidation and reduction occur simultaneously. What that means? One time there will be reduction, another time there will be reduction followed by oxidation, oxidation followed by reduction, that is simultaneously. Okay. So basically, redox reactions are those reactions in which oxidation reduction process occurs simultaneously. Okay. Clear? Now, everyday redox reaction, we can include your respiration, photosynthesis. These are the reverse of each other, right? Now, combustion of coal is also a redox reaction. So, photosynthesis and respiration are reverse to each other. How we can say that? So, in the respiration, glucose, C6, H12, O6, that is glucose, glucose combined with oxygen that is present in your body cells. So it will be forming CO2 and H2O with evolution of energy. That is what we call respiration, right? But in case of photosynthesis, you can check we have CO2 plus H2O in presence of sunlight. They are forming their food, C6H12O6, and O2 is released. So basically these two reactions, you can see this is the reactant side, and here if you compare this reactant side in photosynthesis, that is the product side. That's why we call them reverse to each other. So these are the redox reactions. Now oxidation, one by one we will be discussing about. First is oxidation. Oxidation itself means, as the name represents, oxygen, requires oxygen, wants to eat oxygen. So addition of oxygen, if it has eaten oxygen, so there is no requirement of any other, so it will be removal of hydrogen, and in the terms of electron it will be loss of electrons. This negative sign represent loss. Okay, the positive signs represent addition. Okay, are we clear with this? This is loss. So that's all about oxidation. Let's have reduction. What is that? Reduction is exactly opposite to oxidation. So here in the reduction loves hydrogen. So there will be addition of hydrogen. If in the case of reduction, hydrogen is being eaten up, so what, there will be removal of oxygen. Of course, only one thing can be eaten up. So there will be oxygen that will be removing from the reaction and gain of electron. That's all about reduction. That's all about reduction. Even in our syllabus, there is nothing related to electron losing and gaining of electron, right? We will be discussing reduction in the terms of addition of hydrogen and removal of oxygen. That's all okay. Now see, oxidizing and reducing agents. Some students are very confused. In fact, in the exam, we are being asked what species is being oxidized. What is the oxidizing agent in this reaction? So definitely you can expect one question from here. Suppose I have copper that is burned in presence of oxygen. This is the reaction from your NCERT activity. So copper color is reddish brown. You know now copper metal, that is reddish brown. If I burn it, so if anything is burned, supporter of burning is oxygen. So I am adding oxygen, or there is always, understanding if something is burning, there is presence of oxygen. So you can see, my dear student, it will be forming copper oxide, which is black in color, right? So can you tell me, is it reduction or oxidation? What is it? Addition of oxygen is very much clear. So you can say, ma'am, it is oxidation. Okay, clear? So where is reduction? Let's suppose now what happens, this copper oxide is further, okay, I am going to write one more time. Copper oxide is the, that black color copper oxide residue. Now the hydrogen gas is passed through this. Okay, what's gonna happen? There will be change in color one more time, formation of copper, and water will be formed. So you can check what is happening here. So basically here copper oxide, which was black in color, hydrogen gas which is passing through this black color residue, giving you back the reddish brown solid, and there is formation of water. So what is that? Check it carefully. So what I have to do, I will be comparing. So there is copper in the reactant side, copper oxide, and copper in the product side. Are we good with this? Yes. So for the timing, I am removing this color notation. No problem. So copper will be compared to this copper. You have to compare reactant and product. Copper present in reactant side will be compared with the copper present in the product side. So we will be checking what is happening here. So here I can see oxygen, and here there is no oxygen. So what is happening here? That is the reduction is taking place here. reduction. So reduction is taking place here. Now, if reduction is there, there will be presence of oxidation also. Yes or no? Simultaneously, don't forget that. Now, hydrogen, compare the hydrogen from reactant and product side. So you can clearly see this hydrogen is having oxygen in the product side. So why? Because there is oxidation that is taking place. Now, very minute detail you should notice. What? When we are moving through this arrow, so we will be talking, if this is a reduction process, this species will be reduced or not? Yes or no? So this species is reduced when I compare reactant side copper oxide to copper only. I can definitely say this species is reduced because it has undergone reduction. Is that clear? Yes or no? Okay. Now, this hydrogen, which is alone, now having oxygen with itself, the oxidation process happened. So I can say this is oxidized. Yes or no? It has consumed oxygen, so it will be oxidized. Now discuss about oxidizing and reducing agent. So you can clearly, I will be calling them for oxidizing agent, I will be calling it oxidant. That's so much easy. Reducing agent will be reductant. Okay. Now, as I told you, in the redox reaction, always there is oxidation and always there is reduction. Yes or no? Yes, ma'am. So here you can see already I have discovered the red part. Okay, this red part. Where is the ox part? Where is that? In this arrow, I will be writing ox here. So what is that ox? Can you tell me? Yes, ma'am, that will be oxidant. Yes or no? That will be oxidant or the oxidizing agent. So if I check this ox and this red, they are making redox or not? Yes or no? Of course. Now tell me, if this is oxidized, so what will be this? Let me know. What will be this? Ox is there. Where is red? Reductant. So can you find reductant or oxidant in a reaction? Yes or no? Of course. So you can take more example and can practice more. So this is all about this lecture. I hope you like this and I hope you understood it well. So definitely you can make a promise to yourself. I will end of the story. No more excuses, right? So this is it about the lecture. All the very best for your examination. Thank you so much. God bless you all. Bye bye. We'll be seeing in the next chapter, that is acid, base and salt.